Welcome students. We are going to study problems on trains. There is a formula which is called speed is equal to distance upon time. This is the basic fundamental formula to study problems on trains. You should be aware of the system of units which are followed. If your distance is in kilometers, you will take symbol D for distance. If distance is in kilometers, time is in hours, speed we will take symbol S, and in physics there are different symbols, so we are taking this. Speed will be in kilometer per hour. So this is a set of units which should be followed. One set should be followed at a time to get the correct answer. Now there can be another system also. This is system A. Then there is system B, where distance shall be given in meters and time will be in seconds, and then speed will be in meter per second. Now what if in the question they have given you speed in kilometer per hour, but in options ABCD options you see answers in meter or second or meter per second? It means you have to go from one system to another. Then in case of individual units, if there is 1 kilometer, you can substitute it 1000 meters, or 1 meter equal to 1 by 1000 kilometer. If you want to change hours alone, and then it is 3600 seconds, and it can be in minutes also. Time can be in minutes also. If time is in minutes, then we write 60 seconds. If you have to change the speed directly, some speed, x speed in kilometer per hour, then you multiply it with 5 by 18, you get answer in meter per second. So this is the system. You have to be very aware of the system of units. You should be clear what system of units is being followed. And then basic formula is speed is equal to distance per time. So in symbols I will write speed is equal to distance by time, or from the same formula, distance is equal to speed multiplied by time, or if you want to find time, then it will be distance by speed. So I would say learn only the parent formula, that's all. Whatever values are given to you, 2 will be given out of these 3 values. Put those values and cross multiply and find the unknown value. So don't go into multiple formula. What is the difference between the normal motion of a particle and the problem on trains? The basic difference is that all the moving particles are taken as point objects. They are a point. A point is moving along some path. I will take this path. This is the path, and this point is moving. What happens in a case of a train? Train is not a point object. Train is an object with a sufficient length. In questions it can be 100 meters, 150 meters, whatever can be. It cannot be treated as a point object. So if this train has length L, then it will take some time to cross a pole or a bridge. Crossing means it starts at this point and then this point also crosses the bridge. Entry point is this, and then the train moves forward. And even this point leaves the bridge, then you say that the train has crossed the bridge or a pole. Okay, I think you understand it. Now let's move to the formulae. What are the formulae by which we can solve this problem? I have made various cases. You can put the question in one of the cases. Now for case 1, a train black marker. A train crosses a pole. Here is the pole. This is the pole P. And the train is going to cross this pole. What does it mean? This is length L of the train. If train wants to cross this pole, then train has to move L distance, because the distance will start when the A point is crossing the P point, and the distance will end when the B point will cross P point. This much the train has to move. It means equal to its own length. So first is a parent formula. Speed is equal to distance upon time. In this case, what you will do, speed is equal to length of train by time. If a train is crossing a pole, in place of distance, what you should do, you should take length of the train. And always the primary thing you should keep in mind in quant is the units. Don't forget the units. Units will not be proper. Some of the things might be given in meter per second, some other things might be given in kilometer per hour, time may be given in minutes. So bring it to proper system of units. You know, if a speed of train is say 60 kilometer per hour and it wants to cross this pole, and the length of train is something 100 meter, 150 meter, how much time it should take to cross the pole? It should take only a few seconds. Then obviously answer should be in seconds. In ABCD option you will have answer in seconds. What does it mean? It means if the speed of train is given 54 km per hour or 60 km per hour, change it into meter per second. Length is already okay. So I will take examples later on. Let me explain all the cases. Now I'm going to case 2. Now what is happening is a train is crossing a platform or a bridge. Now platform or a bridge has its own length. It has substantial length. This is small l is the length of the train, and capital L is the length of the bridge or the platform which the train has to cover, has to cross it. Now when the train will cross, it will be in a new position. What new position? The train should be in this new position. This is the new position of the train. When this point of the train reaches this point, then it has crossed the platform. It means how much distance the train has to travel from here to here. This much distance. What do you expect? What is the distance? It is equal to this cell plus this cell. How much this point has moved to reach this point? L plus L. So what is the parent formula is S is equal to d by t. We will modify it. When a train crosses a bridge or a platform, This is the case. Now speed of train, length of train plus length of bridge divided by time taken. This is how the formula will change. Okay, so let us move ahead. Let us see what is the next case. Next case. So now case 3 and case 4 are quite similar. They have a case of two moving trains. Two moving trains say in same direction. Same direction. What does it mean? When you take same direction, it is the case of overtaking. A train is overtaking the another train. This is one train. Adding this is, it has its length L. They can be similar trains also, depends on the question. Now this is another train which is also moving in the same direction. Its speed is S1, its speed is S2, its length is L, this one L. Now that is quite understood that S2 will be greater than S1. That means the train which is behind is faster than this train, and then it will overtake it. How it will overtake it? So when this train will reach this location, let us see, this is green location is a new location for this train, this one. From this point has moved to this point. Now it is a concept of relative velocity. Relative velocity. What do we do in relative velocity? We do not take actual speeds, we take relative speed. What happens in that? One of the body can be understood to be at rest. Actually it is not at rest. This train is also moving, this train is also moving. But the relative velocity concept makes us to think that this is at rest and then this is crossing it. Now the formula of speed is equal to distance upon time is modified. How much speed we will take? We will take S2 minus S1, the difference of speeds. We must have always observed that when we are traveling in a car or a bus, then other bus is overtaking, then we feel that it is overtaking at much slow speed, and the actual speed of both the buses is high. And why so? Because we are ourselves moving. When the observer is moving, then the speed of other object the observer notices is the relative speed. What is that speed? S2 minus S1. And how much distance we will take? Our target is just this much. This faster train should overtake this slower train and come in this position, and it means that this train, this point has moved to this point. It means it has covered a distance of L plus L, length of both the trains, L plus L, and by time taken. This is the main formula. And don't forget my point again and again. I have seen in many questions in quant that units are not proper, so please take care of it, that Length may be given in meters, time may be in seconds, but speed may be in kilometer per hour. So convert it. Bring one system of units so that we get right answer. So this is for case 3. What happens if the two trains are moving opposite to each other? Let's do it on next page. This is the fourth case. Total of 4 cases. Last case. Two trains approaching each other. Approaching. That means we can write that they are in opposite directions. So one of the trains is this. It is moving this direction with S1 speed. It has its length L. Another train is here at this location. Its length is this L. It is moving this side with speed S2. And we want to study a case when one of the train crosses the other train. What does it mean? When it crosses. So the train which is here. This train, this point is this point. This has moved to here while crossing. So this train was crossing. This was moving this way and this was moving this way. But we will again use the concept of relative velocity. It means one of the trains can be understood to be stationary. Actually it is not, but as a concept, this is stationary and this is allowed to cross. Now again our formula of speed is equal to distance upon time will be modified. Whenever we travel on the road, we always find the opposite vehicles moving very fast. Actually it is just a concept of relative velocity. Our speed also adds to the vehicle which is moving opposite to us. So we feel that the approaching vehicle from the opposite direction is moving very fast, and that person will feel that we are moving very fast towards him, because actually speeds add up. We are both moving towards each other. We are helping to reduce the distance in between us. Both of them are helping each other. So what will be the formula? S1 plus S2 equal to how much distance we have to travel. How much distance this train travels to cross this train? Not only this distance small l, also this distance capital L of this train. So distance will be L plus L by T. So we are very clear now that what are the 4 cases, and I have seen that we can cover the questions with these 4 cases, one of the 4 cases, S1 plus S2, L plus L by T. We can do some sample question if you need to, just to understand that how we apply this question, how we apply this system. A train is moving at a speed of 54 kilometers per hour. The length of train is say 100 meters. In how much time or duration we can do? Will the train cross the pole? So it is of type 1 because train and a pole is given. What is speed of the train? 54 kilometer per hour. If I have to change it into meter per second, then I will multiply by 5 by 18. This will be cancelled at 3 and it will be 15 meter per second. Speed of train is 15 meter per second. What is length of the train? 100 meter. What is the formula we wrote in case 1? Speed is equal to length of train by time taken. The case where a train is crossing a pole. So speed is 15 meter per second. Length of train is 100 and t is time. Now your time will be in seconds. T will be here, 15 will be below, 100 by 15 seconds. Then you can do a little bit of more calculation to bring that answer 20 by 3 and 6.66 seconds. So what point I was telling all through that now the speed of train is in kilometer per hour and then length is in meter and the options ABCD options to find the time will be in seconds. Why so? Because the train takes only a few seconds to cross a pole, so it is sensible to convert into system of meter per second. So I had this wrong system kilometer per hour, so I converted into meter per second. Then I use that case 1 formula because the question belongs to case 1. This is how we apply. So thank you students, I hope you have understood it, and thank you very much again. Take care.